Is my screen visible to you? I'm sharing this text pad.
Yes, visible.
Okay, fine. Thank you so much. Thanks for joining and welcome you all. This is our first day in CCNP ENCOR classes. Okay, so let's start from here. We'll cover some of the basics today. I have enlisted over here, but let's see how much we can cover. Now, can you tell me about what is OSI model or the TCP IP model that we have? Any thoughts? Whatever you know, please share. OSI model, anybody?
The
It's
first
a conceptual model.
Mm-hmm. Yeah. Go ahead.
It's a conceptual model to understand how the packet is encapsulated from the layer 7 all the way down to layer 1 and passed around through the network.
Correct. Yeah. Anything else? Yeah, it's a conceptual model for packet or rather data encapsulation / decapsulation in various layers, right? Total 7 layers, but all are conceptual that we have in our OSI model, right? Anybody else have anything to add?
The OSI model total 7 layers. The first layer, I think that's related to application. So the remaining, the last 3 is working for the that's a data and the frame. That's for the network layer. As I understand, so I'm just delivering to you.
Yeah, sure.
It's from converting from physical application layer to the physical layer, how the data is delivering from packet to frame, then it's coming to the application. That's what I understand.
Correct. Yeah, you are right. So these are the 7 layers that we have in our OSI model. Starting from application, this is my top layer, also known as layer 7. Okay, I should have put it in another way actually. Let me do it quickly. This will be your layer 6. Then layer 5, layer 4, layer 3, 2, layer 1. Okay, so on a high level, application layer is basically the interface between a user and your actual computer or the networking device. I wouldn't say networking device, but yeah, any of your computer, your laptop, your iPad, whatever you are using for receiving and sending the data. Presentation is how we are formatting that data. What kind of encryption are we using into it? Okay, what is that format? Session layer, it is to tracking our packets that are being communicated. In transport layer, it is for measuring the end-to-end communication between a source and a destination, right? Network layer is our layer 3, where we have logical IP addressing and the routing of our packets. Then at data link layer, it's about hardware addressing, your MAC addresses, your Ethernet, that is coming at your data link layer. Physical layer, how your data is being transmitted in what format. For example, in your Ethernet cable, it is being formatted in the form of electrical signals. In your wireless, it is being transmitted in the form of electromagnetic signals. In your optical fiber cable, it is being transmitted in the form of light signals, okay, or the optical signals. So that is our physical layer. Data link layer, as I said, this is your hardware addressing, and your MAC address is Ethernet, that all being classified at your data link layer. Similarly, your network layer is your router or your IP addresses. Okay, so majorly within these courses of our networking, will be focusing on these data link layer, network layer, and somewhat around transport layer. These application presentation session, they uh, normally they comes under the application developers. Okay, because we being a network engineer, so we primarily focus around our network only. Okay, that's where I wanted to clarify this thing. Right now, if I try to draw something over here, let's say this is your computer 1. Okay, and it is connected to, let's say, some switch or whatever way. I mean, let's not talk about any switch or a router as of now. We just think of that this is connected to another computer. Okay, and they both wants to talk to each other. Right now, within this computer, there would be some application, okay, which is trying to talk to another computer. This computer may be a server, maybe a client, whatever you want to call. I'm just calling them in general as these are the two computers who wants to communicate with each other. There would be app or a server application that is running over here. They both wants to communicate. Now, what will happen at an application layer? For example, you are using Internet Explorer, okay, or your Google Chrome, right? So these applications, they will be classified at your application layer. How that data is being presented in the form of HTML or whatever way we are doing, that is coming under presentation layer. Okay, session layer, I'll not talk. I don't want to confuse you over here, because this is being concatenated actually in your, if you have heard about TCP IP model. So these 7 layers have been shrinked, or they have been lowered down into the 5-layer model only. So wherein we don't have any session layer at all. Then in the transport layer, how this data is being sent to this computer too. Are we using UDP as a protocol, or we are using TCP as a protocol? So these are the two protocols that work at your transport layer. Okay, one is your connection oriented, another one is connectionless. For example, just to give you a glimpse, UDP between TCP, if you are calling someone, okay, from your mobile phone, so that is a kind of TCP connection. Why we are calling it as TCP connection? Because you call another person from your mobile, okay, bell is going, I mean, his phone is ringing. Then once he picks the phone, then he said hello. Okay, you also say hello. So whatever packets you are getting, you are acknowledging them. It is connection oriented protocol. You have first built a connection, then over that connection then you will be sending your actual data. Okay, however, in case of UDP is like you have posted an email, okay, or you have sent an email to him. Whether that email has reached to him or not, you are not going to get any acknowledgement back. Okay, and it is not being sent on the real time scenario. It may be sent, let's say, after 5 hours or 4 hours, whatever way. It's not real time. So that is the difference between our UDP and the TCP protocol. Then coming at the network layer. So at your network layer, this computer will also need to have an IP address. Let's say I'm having this IP address. Okay, this computer will also have some IP address. So this IP addressing, their routing, their reachability, everything comes under network layer. Correct? I mean, how to make this reachability, that is coming under your network layer. Then data link layer, okay, these two are connected, for example, via Ethernet cable. So at the Ethernet layer, we will have a MAC address of each device. Okay, so how it is happening is, let's say this was my actual data. I'm sending hello message from computer 1 to computer 2. So this hello message will get encapsulated with a, let's say, TCP or transport header. Okay, at transport layer, we are adding a TCP header. At your application and presentation, we are just changing the format of this data. Okay, then this transport layer is heading a transport header. At your network layer, we are adding a IP header. And these headers also have their own size. For example, if I consider this TCP header, 20 bytes, IP header, again 20 bytes. Okay, within this header, they have different fields also. For example, this TCP header will have some source port, okay, destination port. This information it will have. IP header, it will have source IP address, destination IP address. There are few other fields also. I'm just telling you at a high level. That's how. Okay, and then coming at your data link layer, then again, I'm adding another Ethernet header or your data link layer header that you are adding. Then this entire stuff will get modified at your physical layer. Modified means it will be sent if this is an electrical cable, okay, or it's an Ethernet cable, copper cable. You will be sending it in the form of your electrical signals. What happened? This is C1, C2. You are going to communicate with them. Okay, and this was your actual data. Then on top of that, you are adding TCP header. I mean, we are not adding, your computer or your equipment will automatically add. Okay, then IP header, then your Ethernet header will be added. Right, Ethernet header will have source MAC, destination MAC, source IP, destination IP, source port, destination port. Right, so this was the actual data. For example, I'm sending a hello message. So that's how it will be sent. Well, okay, if this was an electrical cable, it will be sent in the form of electrical signals. Okay, if it would have been a wireless communication between these two, okay, for example, we are using Wi-Fi, this will be electromagnetic signals. If it is a fiber cable, optical signals. That's how it will be transcoded and then transmitted. Once it reaches to the other end, what he needs to do is he needs to decapsulate that. I mean, it will remove that Ethernet header, then it will see, okay, this is the IP, this is the destination IP. Does it belong to me? Okay, yes, it belongs to me. It will remove that IP header also. Then it will check this destination port, let's say port 80. Is there any application or a server or that is there at my end who is serving for port 80 on this particular IP address? Okay, yes, I have a web server application that is running on myself. I'll remove this TCP header. Then this is the actual data that will be passed on to your application itself. Is that clear? Any question, any doubt about this communication? Fine. Okay. Let's move. Another thing. Okay. I can delete this one. Okay. If nobody have any question, let's move to. Can anybody tell me what is difference between a hub and a switch? What is a hub? What is a switch? How did How do they differ with each other?
Switch learns MAC addresses, but hub broadcasts the messages.
Exactly. So what do we mean actually? Why we need to learn the MAC addresses? Okay, first thing, as you said, okay, I'll note this over here. Hub does not learn/maintain any MAC table, right? However, switch learns and maintains MAC table entries. Okay, now I delete this one and think that this is your computer connected to a hub. Okay, and on this same hub, I'm having another computer and let's say few more. Okay, and here also let us assume there are 4 ports on this hub and there are 4 computers. Each PC will be having its own IP address. Let us assume this is .1, this is .4, this is .3, this is .2, right? Now this is a hub and we are saying that hub is a device which does not learn or maintain any MAC table. Okay, so what I can do is I am being used to connect multiple devices onto the same domain. Okay, but I'll not learn or I'll not store anything. I'm not an intelligent device. I don't have any memory to store that information. Right? That's what we are saying. Now, what will happen is if let's say C1 is sending some packet that has to go to C2. Correct? That has to be destined for C2. What will happen? Let's say I'm sending a ping packet, right? Let's try to understand in the same way. This is my data. After that data, I'll be having, do I have any transport header? TCP or UDP? Let's not confuse transport header. Let's assume that this is having an IP for header, having source IP and having destination IP. Correct? Source IP is 10.1.1.1. Destination IP is 10.1.1.2. Okay, this is our Ethernet cable. So you all know that if it is an Ethernet cable, I need to attach a Ethernet header. So within that Ethernet header, I should have source MAC and destination MAC. Yes or no? Source MAC, let us assume source MAC was this one. MAC is also always how many bytes? Size of MAC address. Anybody?
It's 60.
Size of MAC address is 48 bits. Okay, so every network interface card does have its own MAC address, right? But in order to build this frame at Ethernet layer, okay, I'll write this over here also. At data link layer, we call it as frame. At network layer, we call it as packet. Okay. At transport layer, we call it as segment. Okay, this you should be aware. Now, the C1 has to send a Ethernet frame. Okay, Ethernet frame will have a Ethernet header. This is source MAC. Source MAC is, let's say, all is, right? And this C2 MAC address is, let's say, BBBB. Okay, now assume that I myself is C1, and let's say Sahul, you are acting as C2, but I do not know what is the MAC address of Sahul, which is double B. Okay, but I do not know. But in order to create this frame, I need to populate this field. Yes or no? I need to populate this field, then only my frame will be complete. So, but I do not know this MAC address. How will I get this MAC address? Anybody can tell me?
Request.
You need to request it, correct? But you know the IP address. I know that the IP address of Sahul is 10.1.1.2, but I don't know the corresponding MAC address. So from IP to MAC, I need that information. I need to send a request. What kind of request it will be?
ARP request.
ARP request. Very right. ARP. So ARP stands for Address Resolution Protocol. You need to resolve this IP address with the MAC address. Correct. So what C1 will do is C1 will first send a ARP request. And this ARP request is always sent as on a broadcast address. Okay. When I say it is sent at a broadcast address, firstly, that means okay, now this will be another request. Okay, within this ARP, my packet is of ARP request, right? It is having that source IP, this one. Destination IP should be 255.255.255. What happened to this one? Okay, and then what is the MAC address of, what is the destination MAC address for this ARP packet? Anybody? We said this is should be broadcast. So that destination MAC address should also be a broadcast MAC address. Okay, the broadcast MAC address becomes your all F. Okay, so this broadcast is being sent to all C2, C3, C4. It will be sent towards all. Only C2 will respond you back, and that response is known as our reply. In this reply packet, what I'm sending back is I'm sending my MAC address, that I am the one who have this IP address 10.1.1.2. Now C1 knows what is the corresponding MAC address against this IP address. Now I can populate that information in this frame and send that frame towards my hub. Okay, now this frame has reached to your hub. So far, any questions from anyone? Is that clear how a host or how a computer is getting this information about destination MAC and why it is required? You should be clear why it was required. Because I'm connected via Ethernet interface. This is a Ethernet cable. So at your Ethernet, you need to create a frame which is having a Ethernet header. Within that Ethernet header, you need to populate these two fields. That's why you require that. And how you are getting this information? Via ARP protocol, address resolution protocol. Clear?
Yes.
Yeah, I just have one question, if you don't
Yes,
mind.
please.
The reply, will it be a unicast? Because a hub, as far as I understand, is a single collision domain. So any frame it will receive, it will just flood from all the ports.
Yes.
Or so it will, once C2 reply to C1, it will also reach C4 and C3.
It will also reach C4 and C3, correct? Correct. Yeah, from hub perspective, yes, it will be. Actually, I have not yet covered hub. Yes, it will be broadcasted at a hub level. Okay, it will be broadcasted. But from C2, when we are sending back, it is a kind of unicast packet. Because C2 now knows this is the I mean, from C2 perspective, my destination IP address will be 10.1.1.1, and destination MAC, he also knows it is AA. Right? From C2 perspective, it is unicast, but at a hub level, he will broadcast. I am coming to that point, hub, for a hub perspective. From C1 perspective, I hope this is clear with everyone.
That's clear. Thank you.
Okay. Now C1 has sent that packet or sent that frame actually towards hub. Now what hub needs to do? Hub has received a frame, okay, which he has to send to this destination MAC and this destination IP. Hub, we are saying that it is working at a data link level, or rather a physical level. Okay, I'm getting something. I need to send it to a destination. Am I aware of that destination? Because I'm not maintaining any table. I don't know where this MAC address is. I'm not maintaining. What I will do is I will broadcast that packet or that frame, whatever data I'm getting, to all the ports. But I can do only this much of optimization, that on which port I received, I'll not send it back from there. This much optimization I can make. I'm only intelligent up to this level. Okay, so every packet that hub will get, he'll need to broadcast that packet. Okay, if I'm sending a packet to this direction, at the same time, I cannot receive any packet. That is why hub is also known as, it works in a half duplex mode. Hub works in half duplex mode. Switch can work in full duplex. Okay, half duplex means if I'm sending something, I cannot receive at the same time. So my capacity or my bandwidth, it reduced to half. Okay, every information or every data that hub is getting, he needs to broadcast, because I'm not maintaining any table at all. I do not know where it is, where it has been destined for. I only know that I received on this particular port. Now where to send, I don't know. I'll send it to everywhere. The recipient may need to decide whether he want to receive that information or he want to discard that information. Is that clear about hub before I move to switch? Anybody have any question on hub? Okay, now one more thing. So what we can say is, if let's say hub is sending something, okay, because he is sending on all the ports, at the same time, if somebody else also starts sending, what will happen? A collision will happen. Okay, a collision will happen and that packet will be dropped. He needs to send it again. So that's why we are saying that this hub is having a single collision domain. All the ports are in single collision domain. Okay, and single broadcast domain also. So all the ports of a hub, because I cannot configure them into different VLANs or different broadcast domain, they always get all the packets. Okay, because I'm doing the broadcast. So all the ports are in a single broadcast domain. For example, we all are connected to this Zoom link. Whatever I am saying, you all are getting that information. So we all are in a single broadcast domain. Right? Now, if I am also talking, somebody else also starts talking, our voice will collide, right? We won't be able to hear each other. So we all are kind of connected to a hub, and we all are in a single collision domain and a single broadcast domain. Is that clear with everyone? Concept about collision domain and broadcast domain.
Yes.
Right? Okay, let's move to switch now. I'll delete this one. Let us assume now that our computers are now connected with a switch. Right? They are having their own IP address, .1, .2, .3, .4. Right? Now switch, we can say that this is an intelligent hub. Why? Why intelligent? Because I have a memory. I have intelligence to learn and maintain the MAC addresses in a table. I maintain a MAC table. Okay, I maintain a MAC address table. So switch will learn in the MAC table port and MAC address. Let's say this is my port 1, port 2, port 3, port 4. On port 1, as soon as you receive a port, I will capture the source MAC and populate my MAC table. Okay, so this information switch is maintaining. Now, if in the same scenario, if C1 wants to send any packet or to transmit any data to C2, that ARP concept is still there because C1 needs to learn the MAC address of C2. Okay, that ARP request and ARP response, that will still be there. But okay, once C1 has known the MAC address of its C2, C1 is sending an Ethernet frame towards switch. From that switch, from that Ethernet frame, okay, now R1 does have this information. Oh, sorry, switch does have this information. So switch will check within that Ethernet frame, destination MAC address is this one. And this MAC address is reachable via port number 2. So he will only send that out from this port. Port 3 and port 4 will not be getting any information. So you have saved the bandwidth or the utilization of rest of the ports by maintaining this table. That's why we are saying a switch is an intelligent hub. Any question? Okay. Now, C1 and C2 both are talking to each other. Let's say C3 and C4, they are also talking to each other. Are these two traffic? One is between C1 to C2. One is from C3 to C4. Are they both colliding with each other? No. Because switch knows, okay, whatever traffic I'm getting from or which has to go to this C4, I need to send it to port number 4. If it is coming back, I need to send it to port number 3. This is individual, this is individual. So what does that mean is within our switch, all ports are in separate collision domain. Does anybody have any question on this line? All the ports are in a separate collision domain. Okay, let's say C3 at one moment, C3 is sending some packet to C4. And at the same time, C4 is also sending that packet to C3. Okay, C3 to C4 and C4 to C3. what switch needs to do? Switch will only check the destination MAC address and will send it accordingly. So both the things can happen at the same time. That's why switch can work in a full duplex mode. Sending and transmitting can both happen at the same time. Correct? Now let's talk about the broadcast domain. What is a broadcast domain? Can anybody tell me? Anyone?
So the last IP address of the network.
Last IP address of the subnet. Okay. 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 Anything else?
It sends messages to every host in the network.
Correct. Correct. Yeah. Okay. So we are saying two things. I'll try to write it over here. Huh? Broadcast. Or let me write over. Basically, a domain means what? Domain means an area or a set of devices which belongs to same broadcast domain. That's how we can say. Set of devices or hosts which belongs to same broadcast area. Correct? Now, we all are, let's say, this is a room. Okay. There are 10 people sitting in this room. If I say something loudly, everybody will be able to listen that. Yes.
Yes.
So what we can say this is my broadcast domain. Let's say there was another room. Okay. Doors are closed, and let us assume that acoustics are like this, that a voice from one room is not going to another room. Okay. This person is still speaking. There is another person over here. Will he be able to receive the voice from the other room? No, I'm not receiving. That means if this was broadcast domain 1, this is some other broadcast domain. So the broadcast area are separate. The packets or the broadcast messages that are being sent are confined to this area only. That's what we are saying. Set of devices or host which belongs to same broadcast area. So this broadcast domain is actually this area in which all the hosts or all the devices can receive each other's broadcast messages. Is this concept clear? Broadcast domain.
No, the broadcast domain, it's reaching, like as you said, the one room in, it's a concept of VLAN.
I'll come to that. I'll come to VLAN, but in general, you understood about a domain or a broadcast domain. In network terms, yes, it will be called as VLAN. VLAN 10 is separate than VLAN 20. Any traffic which is being broadcasted in VLAN 10 will not receive as it is in VLAN 20. I'll come to this point also. But in general, a broadcast domain as a English word, are you able to understand?
Yes.
Anybody have any doubt? Please let me know. This is very important. I mean, in most of the interviews or this is conceptual actually. You should be very much clear about this thing. That's why I'm trying to take general examples, not jumping to the directly onto the VLAN. Okay, so if this is clear, let us now think that on this switch, if C1 is sending a broadcast packet, I am not intentionally sending this to C2. Okay, I'm sending it as a broadcast packet. Broadcast means, let's say 255.255.255.255. On this address, I'm trying to send that packet. Can anyone tell me, just few minutes back, I told you about one of the example of a broadcast packet. What was that packet? We saw an example of broadcast packet. Anybody? Okay. How C1 was getting the MAC address of C2?
ARP request.
ARP request.
ARP.
What kind of packet it was?
It will be broadcast.
Broadcast. Right? So this is my broadcast packet. So who will receive this packet?
Everyone with the same broadcast domain. I mean, if the computers are connected in different VLANs, obviously there will be a problem. But assuming that it is in default, so all the hosts will receive.
All the hosts, right? So broadcast means it will be sent to all the hosts connected by default. I'm taking a default scenario. Okay, let's not jump directly to VLAN. Okay, so this broadcast packet was being received by every host. Okay, irrespective this was a switch, irrespective this was a hub. Okay, now what happens is, let's say we took one step further, that this switch is having more number of ports. I'm having, let's say, 48 port switch. Okay, and within my company, I want to segregate the broadcast traffic within two departments, let's say HR and finance. Due to some security reasons, I want to segregate this traffic. So what we can do is, okay, HR guy may say that, okay, finance person, you can buy another switch, you have more money, and put that switch dedicatedly for your department. That is possible, yes or no? Keep them separate. You connect themselves to all the finance user may connect to switch 2. We are HR, we will remain at switch 1. But this is an additional cost. You need to buy a new hardware, and this is costly. And finance guy will say that, no, we don't want to spend so much money. Why can't we virtualize this switch into two different switches? Can we put some virtualization over here and divide this single physical switch into two different logical switches? Okay, then comes the concept of virtual LANs. Earlier, this was a LAN. Now you are dividing this complete LAN switch into two different LAN switches using the concept of virtualization and bringing VLANs into picture. VLAN 10, VLAN 20. Now this VLAN, in other words, what we are doing is the broadcast traffic from one domain will not go into another domain. That was the sole purpose of putting this virtualization at your LAN or local area network level. So this becomes your single broadcast domain. And this is your another single broadcast domain. So a VLAN is nothing but a broadcast domain. By default, within any of your switches, all the switch ports are part of VLAN 1. Still, there is a VLAN. But if we are, they are by default part of VLAN 1. Okay, so they all are in a single broadcast domain. If we specifically divide these ports of a switch and configure them into the respective VLANs, we are basically dividing them into different broadcast domains. I'm not saying that they won't be able to communicate with each other. I am only saying the broadcast traffic from one VLAN will not go to another VLAN. At least as a broadcast, it will not go. Any question? Okay. Let's do one thing. Let's see this practically. Let's say we are having these two switches. Okay. And I'm connecting them together. And okay. I'm connecting them to the switch. 1, 2, and 3. Okay. 3 hosts we are connecting to one switch, and another host I'm connecting to a remote switch. Okay. Oh, let's power them on. And I'm powering only switch 1 as of now. Okay. PC3, PC4, PC5. That's it. This is our switch. So this switch, if you see show interface status, the switch is only a 4-port switch as of now. Okay, if we want, we can add more ports, but only 4 ports are there, right? All this is 0 by 0, 0 by 1, 0 by 2, 0 by 3. Coming to PC3, I'll change the host name as, let's say, PC3. Interface is 0 by 0. I'm configuring an IP address 10. Let's say 1.1.3. No shut. That's it. Correct? What will happen? This port will come up. It is getting an IP address automatically. We have configured show IP interface brief. You can check that this is the interface on which you have configured this IP address. My status is up, line protocol is also up. Correct? So what will happen? If I go back on switch 1, switch, if I check show MAC address table, can you see this? Automatically what happened is, as soon as this interface came up, okay, this interface was already up. This was already showing as connected in the up status E0 by 1. Okay, they all are in VLAN 1. You can see, I told you that by default, all the switch ports are belonging to VLAN 1. VLAN 1, we need not to configure. It is there by default. Correct? And it learned that MAC address also. Can anyone tell me how it learned that MAC address? What was the communication or what was the packet that PC3 sent towards the switch to learn this MAC address? Anybody?
Broadcasting IP address.
So what kind of broadcast it was? Anybody?
ARP.
ARP. Any special kind of ARP? You are right that it was an ARP packet.
ARP request.
It's a IP,
Gracious ARP.
Gracious ARP. It was a gracious ARP packet. Basically, the purpose of gracious ARP is I have been configured with an IP address. I want to send a broadcast message and check if it is not a duplicate one. Okay, I want to send a broadcast message with the source IP as my IP address and destination IP also as my IP address. And I want to check, is there any other device who is having the same IP address? I can show you. See, let's do one thing. On switch, I have still now only configured PC3. On switch E0 by 2 interface, if I start having the Warshak output, and we'll configure PC4 as well. Then we'll see what kind of packet PC4 is sending. Later. Okay, coming to PC4. Let's now configure this. Hostname PC4, interface E0 by 0, IP address 10.1.1.4. As soon as I put a no shut over here, now see, you got a ARP packet. Okay, what kind of ARP it is? It's a gracious ARP. I'll stop this and show you this. Okay, within this ARP, I'm sending my MAC address, sender IP address, target IP address. See. Sender IP address, target IP address. Both are same. I want to send some traffic to myself only. Is it possible? Okay, why it is happening? Because your PC4, okay, you configured this interface which is connected to a switch. You are sending a packet with IP address 10.1.1.4. This is source. And I want to send this, which is destined to the same IP address. My source MAC is this one. My destination MAC, I want to send it as a broadcast. If, let's say, there was a PC5 also, which is also having same IP address, what will happen is I will respond to that ARP message that this IP address belongs to me. And my MAC address is, let's say, 50.50:00. This one will be changed. Then you will come to know that there is a duplicate IP address in the network. That is the purpose of gracious ARP. I hope this is clear with everyone. how your switch is learning this MAC address? Automatically via gracious ARP. And the purpose of gracious ARP is to verify the authenticity or the duplicacy of your IP address. Is that clear? Right? This was
yeah. So can you come one more time, because the duplication I don't understand. So how
okay.
you're
You didn't
finding
understand.
before assigning
Okay.
the IP address port?
Sure. Let's do one thing. I'll quit this one. So far, we have configured PC3 and PC4. You have configured PC3 and PC4, and your switch 1 has learnt their MAC address on E0 by 1 and E0 by 2, right? You have not configured PC5 yet. On PC5, if I configure the duplicate IP address, okay, I'll do one thing. I'll now capture this packet on E0 by 3. Okay, and I'll show you that duplicity. Hostname PC5, interface E0 by 0. If I configure, let's say I wanted to configure 10.5, but mistakenly I configured this one, which is already there. You already know it is configured on PC4, correct? As soon as I make
Yes.
a no shut, what will happen? First of all, if I do a no shut, that interface will come up in PC5 and I'll send a gracious ARP, correct?
Yes.
Right? So let us see then. Okay. Now see, I'll stop this one. See, you send a gracious ARP. First of all, you send this packet. Okay. Within that packet, you send sender IP 10114, target IP 10114, correct? MAC address, source MAC address 50. 50 is of PC5, right? Now you got a, okay, this is same thing. You sent it twice. Then this was the reply message. You get a duplicate use of 10114. Okay. Why? Because from PC5, which one? PC4. I'm already having this IP address. And my MAC address is, let's say, 40:00. I'm not writing complete one. I'm writing the last part only. Similar, this was having this MAC address. You send a ARP, gracious ARP packet, source IP this, destination IP this. It was sent to PC4. PC4 responded, okay, this IP belongs to me and my MAC address is this one. You send, I mean, PC4 is sending a response back saying my MAC address is this one, and it is also saying there's a duplicate IP address detected for this one with this particular MAC, and also is in use by this IP, this MAC address. Is that clear with you now?
Yeah.
Right? At a switch level, if I go back, switch is a layer 2. You are not concerned about IP addresses. I'll not see any duplicate IP addresses because I only see the MAC addresses. I'm only storing those MAC addresses. 3000 or 3000, I learned via E0 by 1. 4000, I learned via E0 by 2. 50000, I learned via E0 by 3, and that's what I am maintaining. Now at PC5 level, you got this message of duplicate IP addressing at PC5 level. I should be, I check, is it showing somewhere? No, it's not showing over here, but it was being generated. I mean, I got that message. Correct. So you have to, let me normalize this. If I'm changing an IP address, I will again send a gracious ARP. Right, broadcast, gracious ARP. What else? Okay, now beginning with the VLAN. VLAN information. Okay, I'll come to that portion. Before that, where is our text pad? Broadcast domain. So all these ports are in same broadcast domain. At switch level, if we are seeing that these all ports are part of VLAN 1, right? So a VLAN is a single broadcast domain. So if I send any broadcast packet from one host, it will be sent to all other hosts, right? Can we verify? Let's try that as well. PC3 IP address is 10.1.1.3/24. 10.1.1.4.24. Right? Broadcast address is the last IP address of this subnet. This one. This is my broadcast IP address. If from PC3 I send a ping packet 10.1.1.255. So this is becomes my broadcast packet. So this broadcast packet, if I receive it over here, I will have a corresponding MAC address also. Let us first see practically. On switch 1, Wireshark, I'll close this one. Let's say I'm first trying to capture traffic on E0 by 1, the one port which is connected to PC3. Now from PC3, if I send a packet 10.1.1.255, okay, let's say I send only one packet. So you received this packet 10.1.1.3. Okay, ICMP packet you have sent, right? It become a broadcast packet. Can you see the MAC address also? Automatically it become a FFFFFF all. Correct? And let's send all the 5 packets. See, from 3, you pinged at a broadcast address. It reaches to 4 and it reaches to 5 as well. Both of them responded. Okay, since this was a broadcast packet. And when switch received that packet, actually the concept that I want to tell you over here is how switch is going to decide what is the broadcast domain of a packet, of a frame. You know that all these 3 ports are in 0 by 1, E0 by 2, E0 by 3. They all 3 belongs to VLAN 1. You received a frame in VLAN 1 or on a port that belongs to VLAN 1. Yes or no? So that frame will only be broadcasted within this broadcast domain. It is decided on the basis of the port at which my traffic is received. Since this port, I sent a traffic from this direction from PC3, it was received at a switch end on this particular port, and this port is in VLAN 1. That's why it was broadcasted to all the ports which are part of VLAN 1. So anywhere we are calling VLAN, it can be replaced with the word broadcast domain. I'm receiving this traffic in this broadcast domain, which is numbered as 1. It will be forwarded to all the ports which belongs to same broadcast domain or same VLAN. That's why 5 and 4 both are responding to all the packets. 5 packets were sent. Against that, 10 responses are coming back to me. Okay, you are sending 5 packets, but you got respond back via 10 different packets because there were 2 hosts who are sending you response back. So 5 I responded, 5 he responded. So total it became 10 responses. Any questions?
The duplicate address we come to through the wire stack only, or by any chance to the network the switch itself to address when we assign the duplicate address. So how we realize that we assign the duplicate address?
It becomes the responsibility of your application that is running. Sometimes, let's say we are running Windows as a operating system on this computer, and you configure a duplicate IP address. And you must have seen that Windows gives you a pop-up message also that this is a duplicate IP address. So your network portion is generating those ARP message and sending those reply back to you. Now it depends on the application or the operating system that is running over here, how he is using those messages back. For example, let's say Windows operating system, he has some utility to give you a pop-up that this was a duplicate IP address. This iOS or IOL router that I'm using, it was not able to generate that message. Okay, so that becomes the capability of the operating system that is running over here. Am I able to answer your question?
Yeah, fine.
Okay. Moving ahead. Okay. Now on our switch, if I show you, okay, another thing is in this table, this is our MAC address table. So this MAC address table is, I told you only this MAC address and the port. Okay, there are 2 other fields, type and VLAN. So VLAN is, you already understood, in which VLAN this entry belongs. And type is how I'm learning this MAC address. I'm learning this dynamically. You can statically also configure a MAC address on a particular port. That can also be configured. Okay, this is the purpose of dynamic versus static. And this dynamic does have a flush timer. Okay, because I have learned this dynamically, I'll keep it for some duration. Then post that, if I'm not getting any traffic from this MAC address, I will flush this entry. By default, I think it is 5 minutes. I think we can check this also. Show MAC address table. Aging time. Yeah, this is 5 minutes. Okay, 300 seconds. This is the default MAC address table aging timeout. You can change this also. This is configurable. Table aging time. You can change this also. Correct? Okay. Show interface status. Okay. Now what we can see is these all interfaces connected. This is the VLAN that it belongs, duplex, speed, and the type. Another command is show interface switch port. Okay. I will show you the interface. Let me show it for E0/1. Okay, E0/1, this port is connected to PC3. I can show you switch port is saying enabled. That means it's a layer 2 port. Okay, on a switch, I can disable this also to make it a layer 3. Layer 3 means I can configure IP address over here. As of now, this is a layer 2 port. By default, all the ports on a switch are layer 2 only. So that's how you can verify switch port enabled. Administrative configuration. Okay, administrative I'll tell you later, but focus as of now operational mode. What is the operational mode of this particular port? It is statically access port. Access and trunk. And trunk. Now we are moving to this difference between access and trunk. Access means this port is connected to a basically one particular host. That's the purpose of an access port. I'll note this down also. Connected to a host. Okay. Another thing is port configured in a single VLAN. Let's stop this one. We are saying this is an access port. Access port, this is configured in a part of one VLAN only. Okay, single VLAN. Let's say this was part of VLAN 1. This is part of VLAN 1. This is part of VLAN 1. By default, this VLAN 1 is already there on your switch. You need not to configure this. VLAN 1, you need not to configure this. Even you cannot delete this VLAN also. That is also prohibited. VLAN 1 cannot be deleted. Okay, this port, you can change this. I mean, you can make this part of any other VLAN also. But before doing that, you will have to configure that VLAN on your switch. I show you. So VLANs. No virtual LANs configured. Okay. Show VLAN brief. It is showing you these all VLANs. This is VLAN 1. It's a default VLAN. There are few other default VLANs also which are reserved. For example, these 1002, 3, 4, 5. These numbers I'll cover later. But understand this is VLAN 1. It is already there. It's a default VLAN. You cannot delete this as well. It is always remain active. You cannot stop this. Okay, all your ports by default are in VLAN 1. If you want to configure these ports in any other VLAN, you will have to first create that VLAN. How to create a VLAN? Go to config mode, VLAN, and give that VLAN number. Okay, let's say I configure VLAN 10. You can give a name also for this VLAN. Let's say I give HR. Show run section VLAN. VLAN database. Actually, it's a virtual device. That's why it is not showing. Show VLAN brief. Otherwise, in your actual or the physical switch, it shows in the show running configuration also, whatever VLANs we configure. If you check via show VLAN brief, it is showing you that there is another VLAN that has been configured now, VLAN 10. Its name is HR. Okay. Now to configure a interface, let's say E0 by 0, you want to configure part of VLAN 10. How will you configure? You will configure switch port access VLAN 10. That's how you will configure. Now this port is configured as an access port in this particular VLAN. Show VLAN brief. Now this E0 by 0, which was earlier part of VLAN 1, it now belongs to VLAN 10. Okay. Oh, sorry, I made a mistake. Rather than E0 by 0, I should have configured E0 by 1. Interface E0 by 0. No switch port access VLAN 10. Show VLAN brief. That's how you can see, or show interface status also will show you which port is in which VLAN. This is with respect to your interfaces. This is with respect to your VLANs. Any questions from anybody? Now these two are different broadcast domains. I hope you understand. Any broadcast packet sent by PC4 will not be sent to PC3 because they are in a different broadcast domain. Right? Okay. Okay. So run interface is 0 by 1. This is configured as access. You interface is 0 by 1. You can manually configure the mode also, switch port mode access. Right? Now if you check show interface is 0 by 1 switch port. Okay, this is the output after configuring this mode. Okay, I'll take another. Guys, please go on mute. Okay, what I want to show you is I'll take this output. This is after configuring this command. Okay, before configuring, how it looks is if I check on another port, show interface switch port E0 by 2, let's say. Okay, can you see this difference? The administrative mode was dynamic auto, but now it became static access. Administrative mode is how you have configured it. What is the administrative configuration saying? It is saying static access. But operational mode is static access. It was also static access. So while troubleshooting, you should focus basically on your operational mode. What is the operational mode? That makes more sense. Okay. Access mode, it was earlier VLAN 1. Now it is VLAN 10 you have configured. HR is the name. Default is the name. Got it? Any question from anybody? Okay. Moving ahead. Now consider that this is VLAN 10. Assume let us configure this also in VLAN 10 and this also in VLAN 10. I have another switch 2, and there is a PC6 connected over here. That he also wants to be part of VLAN 10. I would like to give an IP address like this over here. But this port by default, it is in which VLAN? These two ports.
1.
VLAN 1. Will they be able to communicate PC3 to PC6 in this scenario?
No.
Anyone else?
No, sir.
Okay. What we need to do?
We need to change the VLAN.
We need to change the VLAN, right? Now you configured this as VLAN 10 and you configured this as VLAN 10. Now?
Still no, sir.
Still no. Why?
Yes. Because it's a different switch.
So what?
No, actually, switch 1 is 0/0, not configured VLAN.
Okay. Okay, fine. Let us configure this also on VLAN 10. Now?
Yes, it is communicate.
Will they work? PC3 to
Yes.
PC6?
Yes.
Yes. Anybody have any second thought?
No, it's basically C01 is required trunk, maybe trunk is required to configure to access another switch.
Okay. Wait. Don't jump onto trunk. But before trunk, we are assuming all these ports are in access. Okay, don't jump on the trunk. We'll come to that concept. In this scenario, all the ports are in access VLAN 10. Will they communicate? Yes, no. If no, why? If yes, why? Open discussion. Anything, I mean, if even if you are saying wrong, we'll try to correct it.
No. In switch 1, all ports are configured as access mode and configure VLAN 10.
Correct.
And in switch port, there is no configuration. It will work. No issue.
Okay. Let us configure interface range E0/0 till 3. Switch port mode access, switch port access, VLAN 10. So I have configured all the ports in VLAN 10 now. The interface status, all these 4 ports are in VLAN 10. Correct? Let us power on these 2 also. So what's your say? I mean, will they work?
Yes,
Will they
it will
don't
work.
work?
No, it's work.
No, sir. I think they will not work.
They will not work. Okay. Okay. Let's check that. Native VLAN I have not. Okay, just remember this thing first. Huh? I'm going to tell you this later, but what we are receiving this native VLAN mismatch discovered on E0/0. Okay, on switch 1, E0/0 is showing us several logs which says native VLAN mismatch. Okay, just remember this line, or let's capture this line. We'll come to this later. Okay, so let's configure our switch 2 and PC6 as well. Host switch 2, interface E0/0, switch port mode access. Does this switch have VLAN 10? Do show VLAN brief. I don't have VLAN 10, right? But what I'm going to do is I'm going to configure interface E0/0 in VLAN 10. What will happen? Switch port access VLAN 10. Will it configure, give an error, or what will be the response? Anybody?
It will create VLANs.
It will create VLAN. It will say access VLAN 10 does not exist, but doesn't matter. I will create that for you. Okay, so it has created now that VLAN 10, and this E0/0 is now part of VLAN 10. Same way, now if I configure on E0/1, port access, switch port access, VLAN 10. Okay, show interface status. You can say both of these ports are now part of VLAN 10. Show VLAN brief. You can see this is already configured now. PC6 also, let's quickly configure. Interface is 0 6. Okay. Now everything configured. From PC3, if I try to ping this, they are able to communicate. Okay. Now let us dissect this communication, how it is happening. Let us do that. On this switch 1, I'll try to open this Warshak. Switch 1 E0 by 0. Let's try to see the packets at this interface, E0 by 0. From PC3, if I just send one packet. Okay, you got this. Stop this. ICMP packet, correct? 72 bytes of data. Now on top of that, I have an IPv4 header. Within this IPv4 header, I have source IP 10113, destination IP 10116. Right? So far, so good. Then Ethernet header. Your Ethernet header does have destination MAC, source MAC. Right? On this interface, when we are sending a data out of this one, so ICMP is encapsulated in a IPv4 header. IPv4 header does have a Ethernet header, correct? You remember we discussed this, how your packets are getting encapsulated at each layer. So your original packet is ICMP. On top of that, I am having IPv4 header, source IP, destination IP. And then on top of that, I have Ethernet header, source MAC, destination MAC, and they are able to communicate. Now what is happening? Now this frame, it is reaching at switch 2. Switch 2, this interface is configured in. This interface is configured in. Okay, before that, can anybody tell me this, within this frame, do I have VLAN information? Anywhere, can you see that VLAN information? That this frame belongs to which VLAN? Please pay attention, this is important.
No, sir.
We don't have, correct? And what kind of ports do we have?
Ether, fast Ethernet.
No. Logically, how we have configured them?
Access ports.
Access port. So any traffic, please pay attention this on this line, and you can note it down also. Any traffic that is leaving from your access port does not have VLAN ID or VLAN information or VLAN tag. Please note this down. This is very important. Otherwise, many a times we get confused. Any traffic that is leaving from your access port does not have VLAN ID. I'll note this down also over here. Clear? You have seen this also, right? Now, how switch 2 is going to decide? Switch 2 is getting some frame, which is having source IP, destination IP, source MAC, destination MAC. Switch 2, how switch 2 is deciding that this has to be broadcasted or this has to be unicasted to this host? Guys, please respond.
Because it's in same VLAN, it's unicasting.
If I assume that there was some other machine that was connected in VLAN 20, you receive that frame in VLAN 10. So switch 2 will check its MAC table, because this frame does have source MAC and destination MAC.
Yes.
Correct? This information, this frame have. It is going to check always destination MAC. So within its MAC table, I have several ports connected in VLAN 10. Let's say this is E0 by 0, E0 by 1. This is E0 by 2. And E0 by 0 is, let's say this one. E0 by 1 is connected to PC6 MAC. And this destination MAC, if it is matching with this PC6 MAC, it will be sent out of this port. It will never be sent out of PC7. Is that clear how this communication is happening? Anybody still having any confusion? Will it work? Will it won't work? Or do I still need a trunk or not? We have not yet spoken about trunk. So far, everything is in access. Clear?
Sir, we can communicate multiple VLANs even without trunk.
I'll come to that point. Yes, we can.
Okay.
Yes, we can. Okay, but first try to understand the concept. If you focus yourself on this Ethernet header level, then you'll be able to understand anything and you'll be able to answer those questions. Don't try to learn, but understand that what is the information that is going in my frame. And the line which I told you, that anything leaving from an access port does not have any VLAN ID. It only have your source MAC and destination MAC. When you received this on this port, you consider that this traffic belongs to VLAN 10 only. I will only check within VLAN 10 entries at this MAC table. I will not consider this. Then you will be able to answer any of the question. Okay, now take another example. I'll do one thing. I'll delete this one. Think that these ports are in VLAN 10. Okay, this is also VLAN 10. I don't have any VLAN configured over switch 2. So what does that mean?
VLAN 1.
VLAN 1. Right? Now PC3 is still sending ping towards PC6. Will it work or won't? Let's try to understand. Now first tell me the frame being sent from here. It does have a source MAC. It does have a destination MAC. Correct? 6000 3000. Do I have any VLAN information?
No.
No. Okay. This frame reaches at switch 2. Switch 2 received that as in which VLAN?
1.
It received that on port E0 by 0, which is configured in VLAN 1. So on my MAC table, I'll check the entries which are part of VLAN 1 only. Yes or no?
Yes.
PC6 MAC. Okay, I received in VLAN 1. Okay, I know that, okay, this is having PC6 MAC. I'll send it over here and same way I'll respond back. Any challenge? Anybody have doubt?
Sir, they are different network. Sir.
Different network means physically?
No, virtually.
You mean here we have VLAN 10, here we have VLAN 1, right?
Yeah.
Yeah, they are.
So
So what?
Communication should not be possible.
Okay, Abdullah, that's why I was saying focus on this, how your frame is leaving. Do I really bother? I need not to match VLAN from here to here. Na? The frame that you are sending, it does not have VLAN information.
Okay.
Okay, so if somebody asks you, will that work? Please think through it before answering immediately. Think, does I have VLAN information going? No, because this is your access port. Let's verify that also. I mean, to interface arrange E0 by 0 to 1 switch port mode access switch port access VLAN 1. Okay, now all the ports interface status, all the ports belonging to VLAN 1 now. Even I deleted this VLAN. I don't have any VLAN 10 on switch 2. Okay, from PC3. See, working? Anybody have any doubt? Is that clear with everyone?
Yes.
Yes, sir.
Yeah, it's clear.
Okay, so I would again reiterate whatever we have understood so far. This one, this is very important line. Huh? Traffic leaving from an access port does not have VLAN information or VLAN ID. Okay, now I hope you will be able to answer any of the question so far. If it is only talking about access port, I have not yet told you about trunk ports. I'll come to that point. But access port, I hope you will be able to understand. Doesn't matter if it is in VLAN 10, because this VLAN information, if I'm talking about access, this is local to this switch. I'm not passing this to another switch. Correct? Now, somebody was asking me a question. So far, we were talking about only one VLAN, VLAN 10 or VLAN 1. If on the same switch, PC3 and PC4, they were part of VLAN 10. And this PC5, let's say this is part of VLAN 20. Now there is a challenge. Why there is a challenge? And on this port, okay, between switch 1 and switch 2, you need to pass both these VLANs. How it will work? How they are going to work? Let me try to use different color. Let's say this is VLAN 10. Okay. Assume this is VLAN 20. This is blue color. I have one wire between switch 1 and switch 2. This blue color wire port, this is in VLAN 20. Sorry. What you can do is, let me put another port and connect it over here. And that belongs to VLAN 10. Now they will be able to communicate. There is no challenge. But let's say I have 100 VLANs. Will I put 100 different links? Because link is costly. This does have a cost. And we don't want to put extra cost. We want to reduce our cost. So we want to pass my data belonging to different VLANs onto the same link. Are you able to understand the need of a trunk? You could pass or you could use different VLANs between two switches using access port only. But for each access port, you need to put in a different VLAN. That's why you will have to configure different links between them. On one interface, you cannot configure in a two different access VLANs. Access VLAN 10. If I configure access VLAN 20, what will happen is this command will overwrite this one. Okay, so an access port can only be part of one VLAN. However, a trunk port can accommodate more than one VLANs. So this was the need of configuring a port as a trunk. Anybody have any question? You understood the need of trunk or the significance of having trunk?
Yes.
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 Okay, because you want to save the number of links between switches. So on the same link, I want to send multiple VLAN traffic. Okay, now if I want to send traffic for VLAN 10 and traffic for VLAN 20, you want to differentiate between these two. Okay, coming to switch 2, you want to differentiate between these two traffics, VLAN 10 and VLAN 20. How can you do that? I'll have to tag this traffic. I'll have to send this VLAN ID along with my data. Then only you will be able to differentiate at this switch 2 level that this traffic which I receive, it is part of VLAN 20. And the traffic that I received over here, this is having VLAN 10 tag. That's why this is part of VLAN 10. So this tagging information you need to send. However, tagging of the packets was not in case of access. That's why we write over here, traffic leaving from access port does not have VLAN ID. But opposite is applicable for your trunk port. Trunk port does have VLAN ID in case of your data packets. And the need you have already understood because we are sending two different VLAN traffic onto the same wire, onto the same link. You want to make it feasible for the other end switch to differentiate or to identify which VLAN this traffic belongs. That's why you need to add this VLAN ID inside those packets. I hope you understand the concept or the need of trunk. Shall we move to configure the trunk? Anybody have
Yes.
any question before that?
No, sir.
Okay. Okay, now within this topology, let's configure link between switch 1 and switch 2 as trunk. You keep in your mind this logs. When I'll tell you about native VLAN, I'll tell you. Okay, E0 by 0. Earlier we configured switch port mode access. To show run interface E0 by 0. Switch port mode access. You need to make this as switch port mode trunk. Switch port mode trunk. Okay, and trunk, because we want to append or we want to encapsulate the VLAN ID information, so there should be some way so that they both should agree. Okay, way means there should be some protocol between these two. It will ask you to put the trunk encapsulation type. Switch port, trunk encapsulation. There are different types. Okay, ISL is a Cisco proprietary way. It's a older protocol, no longer being used these days. So we'll configure .1q. Okay, .1q is a protocol. I'll show you how it encapsulates. Okay, so on this side, I'm using .1q. On the other side also, you will configure like this. Now, what is the configuration? E0 by 0. You need to change this as well. By 0, switch port mode, trunk. I can remove now this one. So my E0 by 0 configuration is now switch port mode trunk. Before configuring it as trunk, you need to define the encapsulation also. This is a mandatory step. Okay, same thing, let us configure on switch 2 as well. Switch port trunk encapsulation .1q. All right, now they both are trunk. Now checking again the status, show interface status. You can see this. E0 by 0 is now no longer an access port. If it would have been an access port, in this command output, it will show you here as a number. But now it is showing you as a trunk. That's how also you can identify. Another thing, show interface switch port. Show interface E0 by 0 switch port. Okay. Earlier, when it was an access port, we were seeing this operational mode as static access. Now it is trunk. Administratively, trunking encapsulation we have configured .1q, and operationally also it is running as .1q. Administrative means what you have configured. Operational means what is operationally how it is operating. Okay, it is operating as a trunk, and you have configured it also as a trunk. It is operating with the .1q encapsulation, and you have also configured it as .1. Correct? Another thing is, okay, we'll come back now. Now, let's do one thing. On PC3, this is, on switch 1, I think we have VLANs. VLAN 10, it is configured on E0 by 1, 2, and 3. Okay, on switch 2, show interface, status. Okay, trunk, but rest of the ports are in VLAN 1. Okay. Now, before going further, see, all these ports are in which VLAN? 10, 1, 1, 3, dot 4, dot 5, dot 6. Okay. Now this is a trunk link. Will they be able to communicate? They are in VLAN 10. These two ports are in. Okay, this is trunk, but this is in VLAN 1. You can see switch 2, E0 by 0 is trunk. Rest of the ports are in VLAN 1. Now tell me, if I try to ping from PC3 to PC6, will it work or not? If not, why? If yes, how?
No, sir, because it's a different network.
Don't say Abdullah like this.
I mean, virtually.
No, don't say like this. Try to do a double click. I mean, as like we did in our previous example, try to answer like that only. I mean, how this communication is going to happen. Anybody would like to try?
Because it will frame tag.
I think
the
it will have a
VLAN
VLAN tag.
Yeah,
in dot
VLAN.
1 encapsulation,
Yeah. Ethernet header.
which
Okay.
won't be decapsulated at
Source MAC, destination MAC. Along with that, I will have a VLAN tag also. Correct?
Yes, sir.
Now, this frame reaches at switch 2. Okay, switch 2 MAC table. E0 by 0, E0 by 1. This will show trunk. And E0 by 1 is in VLAN 1. Where should I send? I don't have any port in, because I will only check within that particular VLAN. Okay, I don't have any port in VLAN 10. Switch 2 won't be able to send it to PC6. But still this frame is reaching till switch 2. Agree?
Yes, sir.
Okay. Let's see that in Warshak output also. Switch. I'll close this one. On E0 by 0, let's capture on switch 2. Okay. From PC3, 10.1.1.6. Can you see this? Your switch 2 was receiving this ICMP packets. Okay, you received this ICMP packet. Okay, good one. Can you see this .1 Q VLAN? This was earlier not there. So between your Ethernet header and your IPv4 header, you have encapsulated another tag of .1Q. 802.1Q VLAN. This is the VLAN ID. In your actual data packet, that's what I was telling you. On your access, if this was your access port, this tagging was not being sent. Because now this is your trunk port, you are sending your packets along with this tag. Is that clear? This tag .1Q VLAN, can you see this 4 bytes? 4 bytes. This is having 4 bytes of information. Okay. If you see, out of this 4 bytes means 4 into 8, 32 bits. Correct? Out of these 32 bits, your first 3 bits are your priority bit for layer 2 class of service. Okay, this 3 bits. This is 1 bit is your discard eligible, or it does have a name also actually. I'll tell you. This 1 bit is having a name, and then 3 bits, 4 bits, and there are 12 bits for 12 bits for your VLAN ID. Okay, and then how many remaining? 16 bits. 16 bits are fixed for 0x800. This one, type IPv4. This VLAN ID, it can be 4 plus 4 plus 4. We can have only 12 bits of VLAN ID. I hope this is clear. These 12 bits can be of VLAN ID. VLAN ID 10. This is showing in hexadecimal format. Oh, sorry, binary format. Right, 1010. So 12 bits means how many total combinations we can have? 12 bits in binary. 2 raised power 12 becomes how much?
24.
Sorry?
40.
4096. That is the reason you can have only this much of VLANs. I can have only 4K VLANs. I cannot have more than that. You may be asked why we have VLAN numbers only ranging from 1 to 4095. Because .1Q tag only have 12 bits. We cannot have more than 12 bits. That's why your VLAN ID range can be till this number. Still, few of them are already reserved. You cannot configure VLAN 1, 1002. I mean, few more are reserved, but this numbering can range up to this level. Is that clear? Any question? Okay. Coming back. So you got this trunk information because you are getting VLAN information, VLAN ID. Now let us quickly configure on switch 2 also. If I configure VLAN 10, name HR, this name is local, need not to match between two devices. I configure E0 by 1 switch port access VLAN 10 switch port mode access. Show interface status. Now this E0 by 1 is part of VLAN 10. They should be able to communicate now properly. Okay, now they are working. Any questions from anyone? Where we are? We are done with our trunk ports. Can carry multiple VLANs traffic.
Excuse me, Gaurav.
Yes, please.
Yeah. So trying to put it as in conceptualize it in terms of what we've also seen. Can we therefore say that traffic leaving or an access port is only locally significant, but it's not, let's say, distributionally significant? That is to say that in light of the examples that we have done so far, from switch 1 to switch 2, the port before in a previous scenario was access on E00 on switch 1.
Yeah.
Now, when it left that port, it could not talk across because an access port doesn't carry along a VLAN tag, which we also saw in the Wireshark traces. However, when we change E00 to a trunk port, and it exited because this time on in a trunk port is .1Q encapsulated, hence it is VLAN tagged. When it arrived at switch port 2, on switch port 2, the access port, which is E01, even though E00 is a trunk, E01 is access. However, in that case, because we needed it to reach PC6, all we needed to do was to put E01 into the same VLAN as E00. And now it brings it all into one broadcast domain. Hence, it can now cross over to PC6. Essentially, what I guess I'm trying to, the idea that I think that I'm trying to ask is that, can we therefore say that the access port is locally significant in the sense that it cannot pass VLAN tags? in a locally significant sense. Because on switch 2, E01 still remains as an access port, but this time around is an access port within the same broadcast zone or the same VLAN as E00 on switch 2.
Partially, yes, partially you are correct, but I would not suggest to use this word locally significant in any of your conversation. I won't suggest you to use this, but your understanding is correct.
Okay.
Okay, but I won't suggest you to use this word. And this
Okay.
makes some different message actually. But your understanding is correct. I agree.
Okay.
That's why I didn't start it directly from the difference between access and trunk. I started from the use case so as to make you understand where I would use a port as an access, where I will use it as a trunk.
Okay.
Okay, it depends actually on the use case. If I want to send multiple VLAN traffic and I want the other end of the switch to differentiate or to identify between two different types of traffic, you will use it as a trunk. And there you need to send that information within those data packets itself in terms of this VLAN ID. That's where you would require this tagging. And here you don't have that tagging because you don't require. See, this is the PC3. Okay, any traffic that is leaving from here out or from switch 2 towards PC6, do you want to send that tag to PC6? Am I really bothered? No, doesn't make sense for me if I'm getting a tag or not.
Yep.
I don't need that tag.
Yep.
Okay, so that's why you have configured this as an access port. So traffic leaving out of an access port does not have that VLAN tag. Right?
Yeah.
Okay. Anybody have any other question? Okay. Now, see, we have configured VLAN 10. This is my trunk. Still, these three ports are in VLAN 10. Switch 1, I said that I still have VLAN 1. This switch also, this port belongs to VLAN 10. And the rest of the ports, let's say E0 by 2. This is part of VLAN 1. Correct? This is part of VLAN 1. Okay, let's do one thing. What I want to do is, I'll configure this intentionally. PC6, I configure this in VLAN 1. And this also, let's say PC5, I configure in VLAN 1. And this I remain it as trunk. The rest of the ports, this one, they are in VLAN 10. You understood the scenario? Yes or no?
Yes.
Right. And then what I'll try to do is from PC5, I will send packets to PC6. And let's dissect those. On switch 2, if I either by 1, switch port, access, VLAN 1. Okay, now this is in VLAN 1. Similarly, on switch 1, E0 by 3, switch port, access, VLAN 1. Right? Show interface status. So this E0 by 3, which is connected to PC5, this is now in VLAN 1. From PC5, now if I send a traffic 10.1.1.6, before sending on switch 2, let us capture E0 by 0. Okay, and now let us send the packets. Okay, you are getting from 5 to 6. Do I have .1q tag? In the data packets, I'm not able to see any .1q tag. Should I have that tag or not? And why it is not showing? This is your trunk. This is VLAN 1. From here, you send a packet. This was sent as Ethernet frame. Within this frame, although this is the trunk link, but you are not able to see that .1q tag. 802.1q tag. I don't have that. Right? Why I don't have is because this traffic belongs to a special VLAN that is known as native VLAN. VLAN 1 is by default your native VLAN. I'll show you. On your switch, show interface E0 by 0, which port? Trunk native VLAN is 1 default. So the purpose of native VLAN is it is first of all significant only on trunk links. Okay. Traffic belonging to native VLAN is sent as untagged. Okay. Traffic received as untagged on a trunk link is considered part of native VLAN. Okay, I'll explain these three statements. You have seen that now the traffic between PC5 and PC6 that is untagged, right? Now what is happening is when you are sending this frame, it is sent as untagged because on this trunk link, you can see VLAN 1 is defined as your native VLAN. So that's why that packet is being sent without any VLAN tag. Now when switch 2 receives that frame, since this is untagged, I do not have any VLAN information. And on this link also, my native VLAN is VLAN 1. I will broadcast or I will send that frame within the ports which belongs to VLAN 1 only. Okay, first of all, native VLAN, it is significant only on trunk links. Okay, must be same on both the ends of a trunk link. You remember you were getting this messages. Why you were getting this? Because on one side of the link, you configured this as an access port VLAN 10. On the other side, the native VLAN was earlier, I mean, by default, it is 1. So that's why you were getting these messages. So native VLAN must be same. It should not mismatch on both the sides of a trunk. Okay, so from one side, if this part is clear, traffic belonging to a native VLAN is sent as untagged. Traffic received as untagged on a trunk link, it is considered as part of native VLAN only. It must be same on both the ends. Any questions on native VLAN? It is used for untagged frames. Okay, VLAN 1 is by default your native VLAN. You can change that also at your trunk level. For example, I configure, let's say VLAN 100. Okay, on my switch level E0 by 0, switch port trunk native VLAN, you can configure like this. You can define any of the VLAN as your native VLAN, but this is only significant on the trunk interface. So it can only be configured at your trunk interface. You cannot configure it globally. It can be different between two trunks. For example, from switch 1 to switch 3 also, I have a trunk link. Here you configured native VLAN as 100. Here you configured native VLAN as 200 because this is being configured at an interface level. So this is possible. It should be same on both the ends. Any questions? Clear? Okay. MAC address table, I've already shown you. Show MAC address table. That's how you will see. On same port, can I receive multiple MACs? Yes, you can receive. For example, switch to E0 by 0. The MAC address is of PC3, PC4, PC5 you are receiving on E0 by 0. Dynamically you are learning. Right? But same MAC cannot be received or should not be received via two different ports. That is a erroneous condition. If same MAC you are receiving from two different ports, there is some error. Questions? Anybody have any question? Okay. Moving ahead. So using this command show MAC address table, we can have different options. You can see it for one particular VLAN. Let's say I want to see for VLAN 10, it will only show you VLAN 10 entries. You can check it statically. I mean, for dynamic, I only want to list down dynamic MAC addresses that you can also do. You want to see for a particular interface, that also you can do. Okay, for a particular address also you can check. Aging time we have already seen. How many total MAC addresses we have learned so far, that also you can check. Okay, per VLAN it will show you. These are the dynamic address count, these are the static MAC addresses. Correct? I mean, this capacity MAC address space available, this depends upon your device to device. Any questions so far? Okay. Another thing, on your trunk port, okay, by default, all the VLANs are allowed, whatever has been configured. Okay, but you can filter them also. Allowed VLANs. You can configure them on your interface level. If I show you show interface E0 by 0 switch port, any of the layer 2 related stuff, if you want to see, you need to append this show interface command with the switch port keyword. Okay, here you will see allowed VLANs. See, trunking VLANs enabled all. Okay, show run interface E0 by 0. If I just allow few switch port trunk allowed VLANs, you can put all, or you can put all except few of the VLANs, add this, or the VLAN IDs you can put. Let's say you put 1 to 10 only. Show interface E0 by 0 switch port. Now it will show you that I'm only allowed to send traffic for these particular VLANs. Rest of the VLAN traffic will not be allowed on this trunk. That is also possible. Any question, guys? Okay. MAC address table. You are learning them dynamically. You can clear them also. Clear MAC address table dynamic. So dynamically, whatever you have learned, they should have been cleared. Show MAC address table. Sometimes in this virtual devices, we have to fire this command again and again, so you can delete them. Okay, this is being stored in your content addressable memory. What else? Okay, coming back. Interface status, I've already told you. Switch port, we have told you. Now, your interface status. Either it is an access port, okay, or it is a trunk port. If I want to, let's say, put one interface as a routed port, okay, for think of another scenario that these ports, assume that from this switch, it is connected to a trunk to a router. Okay, that is also possible. Okay, yeah, let's see that one. From this switch, let us assume this is a router. Forget about this one. This is a router. Okay, on this router, let's say PC3, it belongs to VLAN 3, VLAN 4, VLAN 5. So this VLAN information we will be configuring at our switch level. Access port VLAN 3, access port VLAN 4, access port VLAN 5. Now, they all three are in a different, let's say 10.1.3.3, 24, 10.1.4.4/24, 10.1.5.5/24. And this is my IP address, and my default gateway is, let us assume 10.1.3.1. Here also gateways 10.1.4.1, and here your gateway is 10.1.5.1. Right now, this gateway we want to configure on our layer 3 device. This is my layer 3 device. Switch level, I'm as of now, let us assume this is layer 2 only. Okay, I don't have any layer 3 interface. Right. So what I need to do is, on this router level, I need to configure sub interfaces over here. Let's say this was your E0 by 0 physical interface. E0 by 0.3, E0 by 0.4. This number can be any number, but just for simplicity, I'm matching this with VLAN number. Here you will put encapsulation .1q VLAN ID, because switch, this port is a trunk port. And you already know now, any traffic leaving from trunk will have a VLAN tag. Since this is having a tagged frame, my router should also be configured with the corresponding VLAN ID. Because physically, this is only single port. On this single port, I'll be getting traffic from 3 different VLANs. Yes or no? So that's how you can configure. .1q 5. Now on these 3 sub interfaces, you can configure your IP address as 10.1.1.3.255.255.255.2.5.0. Similarly here, you will configure 10.1.1.4, sorry, 4.1, sorry, yeah, 3.1, and here you will configure 10.1.5.1. What is this called configuration? Anybody? You must have seen this in many scenarios in your production network also. I only have one router that I want to make as a gateway for different VLANs. Are you there?
It's sub interfaces.
Sub interfaces, yes. You must have heard the term router on a stick. So this scenario is called as a router on a stick. Okay, it is configured as like a stick between switch and router, but still it is acting as gateway for multiple VLANs. And why you are putting this .1q command is, you now easily understand, because from the trunk link, this is a trunk, you are sending a tagged frame. So your router should be able to understand that tagging. That's why you are putting the same encapsulation mode over here. Okay, I'll show you this thing. On this switch 2, if I configure this E0 by 0, I want to configure this as a layer 3 port. What I'll do is, first of all, you make it as no switch port. So now it is no longer a layer 2 port. Show run interface E0 by 0. It's now no longer an switch layer 2 port. Now I can configure an IP address. Earlier I could not. If you want to configure a switch port with a IP address, you need to configure first this command, no switch port. This is to make that port as a layer 3 port. Show interface E0 by 0 switch port. This command will not work now because switch port is disabled. This is no longer a layer 2 port. This command is only applicable for your layer 2 ports. Okay, now E0 by 0 dot, let's say I configured .10, because as of now these three are in VLAN 10. So you will configure like this, encapsulation .1q VLAN 10. Interface does not. Okay, this is fine. IP address 10.1.1. Let's say 1. This is the configuration of your interface to your layer 3 level. Now this switch, or it could be a router also. This is working as a layer 3 now. All these PC3, PC4, PC5 show IP route. If I put a IP default gateway as, I should be able to reach that. Any questions? Okay. Can you tell me what is the purpose of default gateway? Why do you configure a default gateway? Or within your PC also, if you have seen the configuration, in your laptop, you have an IP address, you have a subnet mask, and the third thing is gateway. What is the purpose?
It's for routing.
Please explain it a little bit more.
To access other networks, it has to go through that
Correct.
host.
Correct. So see, this is the configuration of my laptop, let's say. Okay, I'm having this IP address and this subnet mask and a default gateway. Now, this subnet mask is telling me what? It is telling me that IP address is ranging from 10.1.1.0 till 10.1.1.255. They are part of same broadcast domain. Yes or no? This is the purpose of this subnet mask. That in order to consider the same subnet, first 3 octets should be masked. They are considered a part of same broadcast domain. If I want to communicate with any other IP, I mean any IP other than this subnet, then I need to send that traffic to my default gateway. I need not to learn anything else, because let's say this is my PC. Should I know that where is Yahoo server? Okay, where is Google? I need not to learn. Na. I can send, because this is PC only. It's not purpose. Its purpose is not to keep all that routing table. I can delegate that work to a layer 3 router. But I'll keep this much of information that if I need to send any traffic out of my subnet, you are my default gateway. I will send that traffic to you. Now it's up to you where you need to send it, in which direction you need to send. That's why it is known as default gateway. You rightly said that if you want to send any traffic out of your subnet, you need to use that default gateway. So that's why in this scenario also, we have configured this E0 by 0.10 as my default gateway. On this PC, I'm having this subnet gateway configured as 10.1.1.1. This is having this IP address. Okay, that's the purpose. So this is one way. You can configure routed sub-interface. Apart from this, you can also configure a layer 3 VLAN ID, SVI. This is also known as switched virtual interface. This was also a logical interface or virtual interface. This is also a virtual interface. Okay, how you can configure is on your switch to level. Let's say I remove this one. You can configure like this. Let me bring back that interface E0 by 0, switch port trunk, switch port trunk encapsulation .1 queue, switch port trunk. Now this port is again a trunk port. On this switch to, if I want to configure a gateway, you can configure it as, let's say, VLAN 10, IP address 10.1.1.1. That's how also you can configure. Instead of configuring this interface as switch, layer 3 gateway, we can configure this as a trunk link. Okay, this port. Here you can configure SVI VLAN 10 and an IP address over this. It's a similar thing, but you are not wasting this port. Okay, that's the difference between your routed port or routed sub interface and your SVI. Any VLAN having IP address, it's known as switched virtual interface. It's a layer 3. Anybody having any question? Okay. Now, this on switch 2, you have configured VLAN 10, right? And let's say you configure another VLAN, interface VLAN 20, IP address 10 dot, or let's say 20.1.1.1. Right now, interface E0 by 1, if I put in switch port access VLAN 20. Now the scenario is, this is trunk. Okay, VLAN 10, VLAN 10, VLAN 10. This is VLAN 20 dot. Okay, SVI, we have configured VLAN 20 also over here, 20.1.1.1, and this PC I'll change as 20.1.1.6. Now this becomes my layer 3 switch now. Since this is a device who will do a routing part also between VLAN 10 and VLAN 20. They are two different subnets. I want to route my packets over here. Okay, On PC6, if I change on switch 1 also, let's quickly check. P0/3 also I'll put in switch port access VLAN 10. Okay, all these are in VLAN 10. Now from PC3, which does have this gateway configured, right? Let me check if it is still working. Okay, admin down. You need to make them no shut. Okay, now they are up. Your SVI interfaces. Coming back to PC3, you should be able to reach your default gateway, right? And same way on PC4 also, if I configure IP default gateway, right? Now PC3 is now wants to send traffic to PC6. Okay, why it's not working? Let's check on switch one. No, sorry, switch 2. IP interface brief. At least from switch 2, am I able to ping? Okay, yes, you are. IP route. Yes, you have routes as well. PC6, we have not configured IP default gateway. Now, if you try to, then it should work. Switch 1, let's quickly troubleshoot. Show interface status. Okay, show interface E0/1, it is in VLAN 10. Okay, E0/0, show interface trunk. E0/0, this is in allowing VLAN 10. Okay, fine. I should be able to reach to my default gateway. First of all, let's check that. Yeah, it was working. Okay, post that, switch 2 should be able to route traffic between these two. IP ARP I have. Okay, and PC6 should also be able to reach its default gateway. Yes, I am. Then where is the challenge? Show interface trunk. E0/0 is a trunk. Okay, we are allowing all the VLANs. Yeah, it should work. Am I putting the right IP address? 2116. Yes. Oh, okay. Actually, why it has happened is no IP routing, because these are not actual computers. These are actually routers. That's why it happened. If I now check show IP route, default gateway is now applicable. Earlier it was not showing. Okay, if I now trace route 20.1.1.6, it should go now. So first hop is my default gateway. Then it should have gone to next thing. Same thing we need to do on PC6 as well. No IP routing. See, now it is working. So now if you trace, or if I show you how it is working, is from PC3, you are sending a original ping packet, ICMP. On ICMP3, you put a IPv4 header, source IP, and destination IP. Source IP 10.1.1.3, destination IP 20.1.1.6. Correct? Okay. Now Ethernet header. Can you tell me what will be the Ethernet header? Source MAC, destination MAC. I'm asking. What will be the destination MAC? Source MAC, let's say PC3 MAC. What would be the destination MAC? Can anyone tell me?
Switch 1.
No, I didn't get your voice.
Hello?
Yeah.
Yeah, switch 1's Ethernet 01 MAC address.
Switch 1 Ethernet 0x1 MAC address. Why is it so?
Because the how do I put this? Because the MAC address. Sorry. Yeah, go ahead.
Router, I was thinking router MAC address.
Who is the router?
Switch 2.
Switch 2. It is acting as layer 3 router. Okay. Now it does have multiple ports. Which MAC address shall we take?
The default gateway.
Default gateway. Correct. So guys, always this destination MAC address becomes the MAC address of our next hop. Okay. This destination MAC address always becomes the destination or the MAC address of our next hop device. Whenever you talk about a next hop, it is with respect to our layer 3. Layer 3 IP address. So my next hop is my default gateway. Within same broadcast domain, layer 3, and I would say within same broadcast domain. So within same broadcast domain, my next hop is this IP address 10.1.1.1. He is my default gateway to whom I need to send this frame. Now it's up to him. Then he will open this entire frame. It will decapsulate, remove this Ethernet header. Then this router will check the IPv4 header where he need to send. So within this PC, till this interface, they are part of same broadcast domain. Right? You agree? This is same broadcast domain. So this VLAN 10 MAC address becomes the destination MAC address of this Ethernet header. Once this frame reaches over here, then because this is a layer 3 router, what it will do is it will remove this header and it will open this IPv4 packet and read this IPv4 header. Now it will check destination IP address is 21.1.6. He knows at switch 2, or because this is a router now, switch 2, I will check route for 21.1.6. I know that this network is directly connected to me via VLAN 20. Okay, and in this VLAN 20, I will check for show IP ARP VLAN 20. Within this VLAN 20, do I have this MAC address against this IP address? Yes, I do have. How this MAC address is connected to me? I will check in MAC address table VLAN 20. Okay, key 0 by 1. Now, if you go back over here, what this switch to, it will create another frame. Original ping is still there. IPv4 header will remain intact. Source IP, destination IP, you are not changing. Only this Ethernet header, which switch 2 had removed before sending it on this link, I need to attach another Ethernet header. Now, your source MAC will be MAC address of VLAN 20. And your destination MAC, how you got? You got via these three things. ARP table, this MAC address. This MAC address you got, you put it over here, 6000. How you come to know that I need to send this traffic to E0 by 1? Because this MAC address you are learning from this port. That's why. So the crux or the summary I want to say is your Ethernet header, source MAC, destination MAC, this gets changed out of your broadcast domain. This was one broadcast domain. Since this is my layer 3 router, this is another broadcast domain. Your router is the one who divides your broadcast domain. Don't go with this word. Actually, physically this is switch, but now it is joining two different subnets. It is doing the routing function between two different subnets. That's why we are saying these are two different broadcast domain, and this becomes the boundary. At each broadcast domain, your layer 2 Ethernet header is rewritten. Is that clear? Let me know if you still have questions. No? All right. Let's put this in our notes as well. Where is that? Okay. Routed sub interface example is, let's say this one, E0 by 0.10, then you'll put command like encapsulation.1q and then VLAN ID. Then you can put IP address. In same way, you can configure interface VLAN 10 also. Okay, here you need not to put the encapsulation part. You will only put this one. Okay, that's it. This is your SVI. Right. Layer 3 forwarding, I told you the main thing is that you should remember when a traffic crosses from one broadcast domain to another broadcast domain, our layer 2 header or Ethernet header is rewritten. Any questions from anybody? Okay.
Sir, I want
Yes,
to ask
please.
about the VLAN.
Uh-huh.
Assigning IP address to the VLAN makes it the broadcast address.
No. We are just defining a default gateway and making this as an SVI. This is SVI, a layer 3 VLAN.
Okay.
And the full form is switched virtual interface. Okay, this is not making it as a broadcast. We are just defining it as a gateway. You could have defined the gateway on the interface also, and you can define a switch virtual interface also. Right? Any other question? All right then. Thank you so much. Okay. Before our next class will be on Saturday, 10 a.m. Indian Standard Time. I would encourage you to go through the recording and all these concepts, whatever we have discussed today. If you have any questions, please note them down. We can take it in our next class. Right?
Right, sir. Sir, will you provide us with this video?
Yeah, this video, as I said, this will be visible in your app or account that you have got from Networkings. They will be uploading this over there and you will be able to see that. Okay. I mean, I will not be able to send this directly to you. This is getting recorded and it will be uploaded in your account.
Okay.
Right? All right, guys. Thank you so much. Let's connect next week.
One question.
Yes, please.
Where we didn't get any username password to the practice the lab that will provide later, or
you will be getting that all the information from networking, guys. You need to reach out to them. I mean, whomsoever is the contact person, please reach out to them to share the rack access or the lab access. You can practice it over there.
okay, fine.
Right? For any of these things, I mean, logistics or the access part, you need to contact directly with networking, guys. I may not be able to help them. But yeah, the only thing what I can do is I can pass on your message if you didn't get any response, I can pass on your message. All right. Any other question anybody have? No? All right then. Thank you so much. Thank you. See you next week.
Bye, sir.
Bye.
Thank you, sir. Thank you for.
Thank you. Bye.